Good afternoon all. This is Satish Kumar, Assistant Professor of EC Department. Now let us see the another video lecture series on realization structures for IIR filters in IIR filter design. Empathy. Why do we need IIR realization? Visual representation of difference equations simplifies understanding of data flow and system behavior used in MATLAB, Simulink, DSP processor and embedded systems. Y of n is equal to x of n into h of n. Visual representation means we can go visual aids for tracking data movement within systems. MATLAB Simulink software platform for simulating and analyzing dynamic systems. And digital signal processing, we can core technology for signal manipulation and analysis. Difference equation to identify the mathematical models representing system dynamics over time. It is used in embedded systems and DSP processes. Next defined part, realization IIR structure. Discrete time systems is of four types: direct form 1, direct form 2, cascade form and parallel form. Direct form 1 is of delays and coefficients. Direct form 2 is of shared delays optimized structure. Cascade form series connection and subsystems. Parallel connection and subsystems in parallel form. The discrete time systems are represented by block diagrams. They are also called as structure of discrete time systems. These are the elementary blocks to represent realization structures for IIR filters. Adder x1 of n added with x2 of n, we can get x1 of n plus x2 of n. Constant multiplier x of n, if multiplied by constant a, we can get output as a into x of n. Unit delay element x of n multiplied with z inverse, we can get x of n minus 1. Signal multiplier x of n multiplied with x2 of n, we can get x1 of n into x2 of n. Advancing element x of n multiplied with z plus 1, we can get y of n is equal to x of n plus 1. Multiplication x1 of n multiplied with x2 of n, we can get y of n is equal to x1 of n into x2 of n. These are the ideate exploding structures. Direct form 1, basic distinct input output stages. Direct form 2, optimized storage using state space. Cascade form, subsystems in series, outputs feeds next. Parallel form, subsystems in parallel, outputs combine. Realization structures for FIR IIR filter. Y of n is equal to y of n minus 1 into x of n minus 1 plus 0.5 into x of n. X of n multiplied with 0.5, we can get 0.5 into x of n, that can be added with y of n minus 1. Y of n minus 1 added with means if we can multiply it by z inverse, we can get y of n minus 1. X of n multiplied with z inverse, we can get x of n minus 1. Now we can get the output structure as y of n is equal to y of n minus 1 into x of n minus 1 plus 0.5 into x of n. Next one, direct form 1 realization. Y of n is equal to a1 into y of n minus 1 plus a2 into y of n minus 2 plus b naught of x of n. X of n multiplied by b naught, that can be added with, we can get the output as y of n. We can multiply a1 multiplied with y of n minus 1, that can be multiplied with z inverse, we can get a1 into y of n minus 1, again added with z inverse, we can get it as here a2 into y of n minus 2. Now we can get the output as y of n is equal to a1 into y of n minus 1 plus a2 into y of n minus 2 plus b naught of x of n. Similarly, for direct form 1 realization, h of z is equal to 1 plus 2 z inverse plus z power minus 2 divided by 1 minus 0.75 z inverse plus 0.125 z power minus 2. This is the direct form 1 realization of the above equation. X of n multiplied with x1, we can get it as a 2 into z inverse multiplied with z inverse, z power minus 2 again multiplied with z inverse, we can get z power minus 2. Y of n means multiplied with 1, multiplied with z inverse, we can get 0.75 into z inverse, again multiplied with z inverse, we can get 0.125 into z power minus 2. Direct form 2 realization, h of z is equal to 1 plus 2 z inverse plus z power minus 2 divided by 1 minus 0.75 z inverse plus 0.125 into z power minus 2. X of n multiplied with z inverse, we can get it as your 0.75 into z inverse. Again multiplied with z inverse, we can get z power minus 2 minus 0.125 into z power minus 2. Y of n means we can multiply it with 1. Y of n multiplied with z inverse, we can get 2 into z inverse. Again multiplied with z inverse, we can get z power minus 2. Next one, cascade form realization. H of z is equal to 1 plus z inverse into 1 plus z inverse divided by 1 minus 0.5 z inverse into 1 minus 0.25 z inverse. Now we can, all the equations are connected in cascade form realization. We can combine all the 4 equations. We can get x of n multiplied with 1. We can multiply it with z inverse. We can get 0.25 into z inverse plus 1 plus z power minus 1. Again multiplied with z inverse, we can get 1 minus 0.5 z inverse into 1 plus z inverse. We can get the output as y of n. Next one, parallel form realization. H of z is equal to 8 plus 18 divided by 1 minus 0.5 z inverse minus 25 by 1 minus 0.25 z power minus 2. X of n multiplied with z inverse, we can get 0.5 into z inverse. That can be multiplied with 18, we can get it as a y of n. Again realization, multiplied with z inverse, we can get 0.25 into z inverse. That can be multiplied with minus 25, we can get it as an output as a y of n. Next one, real world insight. It is used in biomedical signal processing, communication receivers, digital audio filters, adaptive filtering systems, speech processing, embedded real-time systems and control systems. This is the mind map of IIR filter realization structure. The elementary blocks are adder, multiplier, unit delay element, signal multiplier and advancing element. Types of structures are direct form 1, 2, cascade form, parallel form. Real world applications, it is used in biomedical applications, control systems and digital signal processing techniques. Next, we can see the assessment, the why IIR filter realization. See, IIR filter, the discrete time systems are represented by block diagrams, or we can use it to represent to realize the IIR filter design. Mention the structures to represent realization of IIR structures means direct form 1, direct form 2, cascade form and parallel form. The system transfer function of LDT DT system is given by H of z is equal to y of z divided by x of z. List the summary of elementary blocks to represent DT systems, adder, multiplier, constant multiplier, delay element, advancing element, etc. Identify the difference equation. X of n means y of n is equal to a power n y of n minus 1 plus x of n. Thank you.